I promised you guys a deep dive into the shield testing software, both to answer some questions, but also to give you an overview of how the tool works and inspire you to maybe go out and try to write some code yourself. So that's what we're going to do today. This channel is all about sharing knowledge, and this is why I'm proud to say that this video is sponsored by Skillshare, which is one of the largest online learning communities. They have thousands of classes by professionals in their fields on everything from astrophotography to animation, web development, marketing, or business management. All classes are neatly divided into chapters, which means you can follow them at your own pace. And if you sign up with the link in the description, you will get a 2-month free premium membership. And if it turns out it's not for you, just close your account and it won't have cost you a penny. So stay curious. Learn a new skill with Skillshare. Hello ladies and gentlemen, and welcome to Down to Earth Astronomy. So today we're going to take a look at the shield testing software. I've already done 2 videos on it. First original video showcasing some results, then an update with some additional changes that I made to it. And today we're doing the deep dive into the current version of it. I should say the tool is of course available on GitHub, so you can download from there. There will be a link in the description where you can get it. And I just quickly want to also mention that the tool has also been ported to both Go, Python, and Rust. I'm not personally maintaining those. There are other people who are maintaining them and coming with suggestions and feature requests and that kind of thing. But keep in mind today we'll just be focusing on the PowerShell version. And you can see I have, of course, a clone of the Git repository here. And we're going to run through the script here in a little bit, not line by line, but in broad terms explaining what is being done and why I'm doing what I'm doing. But the first question I just quickly want to answer here is, why PowerShell? It doesn't seem like the obvious choice for a tool like this, and you're absolutely right, it's not. The reason why I chose PowerShell was because I wanted a simple scripting language that even a person who's not that proficient in programming could easily pick up and begin to do alterations to. It's also kind of like my own little trying to get more people into coding, because it's definitely needed. And it has the additional benefit, everybody that's running Windows 10 has PowerShell installed. It comes natively with the operating system, so everybody can run it. And I could do something with like a signed exe file, something like that, so people could run it as a standalone thing. But I opted for just something people could run as scripts, even though if I wrote it like C++, C#, something similar like that, I don't know, it would probably have been a lot faster. But let's dive right into it. I just want to take the main file, the 3 main files we have here in the main root of the shield tester, which is the shield tester config, the shield tester itself, and the start test.bat. The bat file was just one I created. You can see it here, it's very simple. It simply just executes the main script, and then it runs a pause because some people wasn't really proficient or had problems opening up a command prompt and running it from there, so the command prompt would close when they were done, so they couldn't see the results because there is no GUI for this tool. So I just made this simple bat file that simply just runs the tool and then pauses and thereby keeps the command prompt open for people. Next up we have the configuration file, and this is where you configure your test. You set up which parameters you're going to test with. Compared to the previous video, what I have added is now that instead of it being hard-coded for the Anaconda, which it was in the original version, I've added different ships. We'll come over that when we begin to talk about it. So basically you just put in the configurations here, like the ship name, the generator, shield generator size, so how big of a shield generator you're fitted, how many shield boosters you have, how much ship pod you have from your shield cell banks, how much you have from your guardians, how much incoming damage you have, explosive, kinetic, thermal, absolute, and the damage effectiveness is how big a percentage of the time are you being shot at. This is important when we are calculating regen rates, because you can only regen shield when you're not being shot at. So that's why you can put this in here. And this 65% I put in is what I measured from a run I did in a high intensity conflict zone. But I'll dive over to the shield tester itself. First thing I do is just some simple logging. I just set up a log directory. I make sure that if the log directory doesn't exist, I'm going to make the log directory. And then I start a transcript, which is just PowerShell, like everything that goes to command prompt now also goes into the log file. And then I just informs the user that this is now being loaded. Then I load some data files that we're going to need here in the beginning. It is the shield generator variants and the shield booster variants. We can see these are located inside the lib folder. So if we go in and pick those up, there are actually multiple data files. We're going to open up all of them now, even though we don't need all of them right now. But the two variants the variants both come in the short and long one. In the short one, I've removed all explosive resistant ones because that would increase the runtime, because again, the PowerShell version is a little slow, but if you're running on a faster version of it, you can use the full one, but in most cases, I don't think explosive is something that will show up anyway. But this just holds information about the different shield booster engineering, so you can see the name of the engineering, the name of the experimental effects, and how much shield bonus strength and resistant bonuses the different one gives. So that's just like hard data on the shield boosters. Same with the shield generator variants. This also just show if whether it's a normal, biweave, or a prismatic shield, what kind of experimental there's on it, and what main engineering and experimental. And then it shows how much bonus you get to the regen rate, what is the shield generator's experimental, kinetic, and thermal resistance with that engineer on it, and what is the optimal multiplier bonus that you get from that engineering, because you can see some of them will, of course, reinforced will give a bonus, and high cap also gives a bonus to optimal multiplier. So all that is just here. So this is just data on the different modules and how they affect the stats of the ship. Then I just quickly detect how many processing cores or processing threads are available on the machine, so we know how much we can parallelize this. And then I just source some of the modules. I sourced the config. I sourced a function called the loadout list. I sourced one up and I sourced test case. We'll come back to these, but basically I just source some of the modules that I need later on, so I have those available for me. Next up, I just import the ship stats CSV file, and I search up the ship name that was given from the config file. And again, the ship stats is quite simply just a list of all the ships that are available in the tool with their hull mass and their base shield strength. I pulled this data off Coriolis. They have all the data files stored on GitHub, so it's very easy to get in a simple JSON format. I threw it over to CSV because it's a little easier often for people to read and understand, because it's closer to like an Excel sheet. But again, this is just base data on the different ships that are being stored in this file. And we're of course just looking up the ship, so we now have access to how heavy the ship is and what the base shield on it is. Alright, it's actually now that I'm loading the different variants. I was just setting the path for them up here. So now I'm actually loading the different variants. I'm also doing that with a test file path to ensure they actually exist, otherwise I'm throwing an error. Then I write some basic information about the setup here. This probably could do with a little bit of maintenance to write some more additional information as more has been added to the config file since this was written. But this is where we encounter the first real function call, the first real piece of work. And that is get loadout list. You can see here it takes the shield booster count and the shield booster variance. And here it is, you can see very well documented, not a single comment in the whole function, so that's definitely easy to understand. But quite simply what it does is it tries to solve the problem that when we have different shield boosters, it doesn't matter which order they're in. So if I have a list of shield boosters, let's say I have just 2 shield boosters in 2 slots. It doesn't matter if I fit shield booster 1 and then 2, or I fit 2 and then 1. So it just tries to calculate for the number of shield boosters, so for how many slots are available, and how many different variants, so how many different variants can we put in each slot, all the different combinations, without being like 2 being the same, just permutations of each other. I hope that makes sense. Basically just by making a unique list. And it does that by just building the first one, which of course this is running on the IDs of the shield boosters. So that's why I'm starting here at 1. It's not running on indexes, it's running on IDs. And you can see my ID list here always starts at ID number 1. So therefore I have 1 indexed the IDs, and therefore I'm starting at 1. But it's simply just build a list that just says 1, 1, 1, 1. So we have 1 all along. And then it runs the 1up function. And the 1up function is a recursive function that finds the next one in the list. What it's basically doing is it takes the first position in the list, and it tries to see, can I increase that by 1? Yes, I can. Then it does that. Now, if that reaches the maximum level, it will then take it and reset it back. It's not just counting up, because we need to get those out of the way. So when, let's say, position 1 reaches the max position, it won't be reset to 1 necessarily, because then you just get the first 2 positions again. You would get 1, 2. But we already had taken 1, 2, where we tested it as 2, 1. It's just a permutation. So it will, when it reaches the top, it will plus 1 on the 1 index 1 further down the list. and then it will reset the current position back to the same level as the next one in the list. So that means it will count up, and again, let's say that there is 3 different variants in 2 different slots. It will then, first one will be 1-1, then it will be 2-1, then it will be 3-1, and then it will count up the next one, so that will be 2, and this will be reset to the same level, so next one will be 2-2. So it goes 1-1, 2-1, 3-1, and then 2-2. Then 2-3, 1 it up, and then 3-3, and you have all the different permutations. This is all this one does. It just has the logic of how to count up for the next shield booster in the list, so we avoid having the same permutation show up multiple times. All this information is being stored in a hash table. Hash tables, again, used for speed, and because it doesn't really matter in which order they are tested, as long as we are testing all of them. So that's why I decided to use a hash table, because we don't really need the orderings, and hash tables are a hell of a lot quicker to use than any array or like the custom PS object that PowerShell natively use. So that's why I decided to use a hash table, and it just returns that hash table to back to the main script, which we then have right here stores at the shield booster loadout list. So now that we have all the permutations of shield boosters that we can fit on our ship, it's time to actually run the actual test. And this is done in this for loop. Each loop, as you can see here, we're looping over the different variants of shield generators, all the different engineering variants on the shield generators and types of shield generators, so all the different normal, biweave, and prismatic ones. And we're just looping over that list, so each loop will take care of one shield booster, because every shield booster needs to be tested with all the different all different shield generators. We're looping over shield generators, and each shield generator will have to be tested with all the permutations of shield boosters. This is being run in parallel. That's why we detected here up earlier, you saw we detected the number of available threads on the machine. So we know how many logical processes were, so how many times we're going to be running in parallel. And we're doing this with the start job. This is basically just PowerShell's like run a new job in a parallel thread. These has to be done with a test block, or a script block it's called, which is just an enclosed piece of code that is going to be loaded. And it's done with this test case, which I believe we loaded earlier in the script. We're going to look at this test case in a second. I'm just naming it with the shield generator ID so I can keep the different jobs apart. And then I just give it an argument list, which is basically just the input variables. So you can kind of see this as starting a function where you give it some inputs, but it's just running in a separate process. Basically, we're starting the job. We're going to have a look at that in a second. I just want to finish this loop here. I basically just have a small while loop here that just looks for jobs that are not completed. And then I'll just check if the number of jobs that are running are less than the number of processes. If that, then we break out of a while loop. If not, we sleep for a second and try again. So here we have the test case with the different variants. We can see we take the shield generator. That is an object. That means it's an object containing all the information on the shield generator. It's actually all the information we have here in the shield generator variants, I believe. So it's all this information with the regen bonus, the resistances, and the optimal multipliers. All this information is available in this test case object. We're also getting a list with all the shield booster variants. We're getting the loadout list we talked about before. And we're getting a script root path. This is just, again, these are being started as a separate process. I think in the user's home directory is actually where it's being executed from. So to kind of tell this test where the root of our script is, we pass that onto the function as well, so it knows where to look. And we can see the first thing, because these are running 100% isolated, we're just .sourcing the config file, loadout stats, and get shield hit points. And we also import the ship stats, just as we did before, exactly the same thing. A little bit of here to kind of get the shield rating. I have a data file here with all the shield stats, and this one actually contains all the way down to also E-rated ones. However, to optimize the test a little bit, we are only running for A-rated or the normal, obviously C-rated on biweaves and A-rated on prismatics. So I'm not running for all the different types of shield boosters. I don't think there's any point in running for B-rated or for lower than A-rate. We import the shield stats just as before, and we use the shield generator type and class to get the right information out of that CSV file. And then we generate the ship hit points, which we have over here. Quite simply, again, we get the shield generator stats in. We look up what is the maximum. Let me show you that file as well. It is right here. The shield stats. Do we have that on my? Oh, we have shield stats here. It was that file here. You can see I have the maximum mass, optimal mass, minimum mass, maximum multiplier, optimal multiplier, minimum multiplier, regen rate, and broken regen rate. It's all in this file. Again, data pulled off Coriolis. So thanks a lot for making that available. But all the function really does is it just calculates based on the math behind it. I don't want to dive too much into the math behind it right now. You can see it here. You can dive into it yourself if you want to get an overview of how the math works. But all it really does is it takes the ship mass and the ship's base hit points as well as the basic stats on the shield generator. And then based on that, it just calculates how many hit points do you get from the unengineered version of that shield generator. Next, we begin the actual test, and the way it's testing it is testing survival time. So we remember in the config file, we put in some DPS, and it's basically saying how long can the shield survive with this amount of incoming damage, and that metric that we are verifying the different builds against. So the one that has the highest survival time, well, that's the winning build. We start by getting the loadout stats. The loadout stats is just where we take the base recharge rate, the base hit points, the engineering information on the shield generator. We get the specific loadout. You can see here we're loading over all the different loadouts here. So we're taking the specific shield booster loadout and information on the shield boosters. We pass that into get loadout stats, and this is just the one calculating all the engineering effects. That's pretty much all it does. I did a video where I went into more details with how resistance work. You can see that more in Ficon if you want to have a deep dive into the math behind this. But again, just like the other one, I don't want to go too much detail with the math behind it. What this function does is it just takes the base stats, it applies engineering to them, and calculates what are the final ship stats for this build. So it calculates the final resistance, the final hit points, and the final regen rate. And all that information is then passed out back to the test case. Next up, we then calculate the actual incoming DPS. So we just take the different DPS that comes in, we multiply it, we subtract like how much is being lost due to resistances. Also remember the damage effectiveness because we're not being shot all the time. And then from the DPS, we subtract how much hit points we are then actually regenerating from passive regen. And then we have the actual DPS, and then we end up with the survival time, of course, just being the final hit point divided by DPS. Then we have the survival time in seconds. Then it just tests if this one is better than the best survival time, and if it is, we update the basic stats on it, which then at the end will build into a custom object that we can then return back to the user. And what we basically get back is an object that contains all the information about that ship, like what shield generator, what engineering, what shield boosters were fitted with what engineering, and what were the stats for the ship, like how much resistance and hit points did it have, as well as how the survival time was. Because remember, this test case here is only testing for one specific engineering on shield boosters. If you go back to the main test here, remember we looped over one specific shield generator. We looped over shield generators out here. So the test case is only working on one shield generator. So we have a similar thing out here where it will run over. So basically when this loop is done and all tests has been started, it says it gets the job, waits for the job. So we just wait for all jobs to finish. And once all jobs have been finished, we just read the outcoming data from them. And we read specifically the survival time. And then we just compare all the different threats. So every threat, every single job has all come back with their best guess on what the best build could be, and then all that is then just being compared out here in the main script again to find the actual best result that's then being tested here. We do a bit of cleanup, just remove the jobs so they're not here. If something goes wrong, then it should be gone for next time. And the final step is just to print out some information for the user so they can see like what ship they were tested with and all. This is basically just printing out the config files showing all that information, as well as all the information on the ship and how it should be fitted with what shield generator and what shield boosters should be fitted. Now, this is by no means the final version of the software. There is no such thing as the final version of the software, only when you decide to discontinue it. That is, of course, the point when you reach the final version. So there might be changes coming to this soon, and if you want to get involved in the project and you have your own ideas for additions, again, head over to GitHub. There's already a lot of people over there who are coming with suggestions, and if you spot a bug or something, well, let me know and I'll try to fix it. But that's gonna be it for today. Thanks a lot for watching. I hope you enjoyed this little bit more techie, nerdy video. If you did, give a like, subscribe to the channel, and until next time, I'll see you guys in space.